So I wanted to go through some framework stuff, and one of the things that I needed to do was be able to see if an object can test a straight line between its position and a position in the world, but also see if it can safely move there in a straight line. So what I needed to do was make a gap checker in this cell phone model. This test model is going to be doing this test, this gap checker, straight line check. So you can see it's changing, and it's green sometimes and red other places, and I'll show you how it works. So I'm going to put him here, and you can see that he is tracing to the mouse position in the world. And you can see he's doing multiple traces, and a trace is actually a collision check, so you can tell by these lines, if the lines hit the geometry of the level, it's green. That means it's safe to walk, and his overall square is green. So that means whatever he's tracing to, or whatever he's trying to check to, it will have a green line. Green boxes means it's all good. Watch what happens when I put this line over a gap that goes into the abyss. See? These lines to the right and on the regular flat ground are green, but there are trace checks that go past the gap. This causes him to return 0 in that check, and it's not safe for him to move in a straight line. So here I can put him up on different things, and he can safely move in a straight line to here. He can safely move in a straight line to here, but he can also move in a straight line safely to this position. And you see how it's still green because I've let the AI favor moving from high to low if it hits something. So if he wants to be here and he wants to move over here, it's safe for him to move in a straight line to here, as well as drop if the drop is safe. But over here to here, the drop isn't safe. I can't let him move in a straight line from here to here, and it will return negative. He will not be safe going in a straight line. The reason why I add this extra check is pretty much the AI, as what you can see here. He needs to be able to do two types of movement. One movement is the pathfinding movement. You can see here he will be able to move around using the nodes, move to node to node, but he also needs to be able to move to a 3D position anywhere, whether it's next to a node or not. So I'll show you. Here's the AI, and I want him to move to this position. So now he's moving, he's doing his pathfinding thing. And when he gets to if he can see his target position, and if he can safely move to that target position in a straight line using that straight line check, he will make a beeline for that position. So let's see it again. I'm going to slow it down. He's moving. He cannot see his target position, but once he gets a line of sight to it, now he can start moving in a straight line. Right? This is the straight line walk test, and he's in this position. That means you can always move to this position. See? I'm moving it with the mouse, but he's always checking that straight line check. Now watch what happens when I move him over here, over a gap. Right? He's okay. He jumps over. Okay. I'm going to try again. And watch what happens when he cannot safely move in a straight line to his target position. See, he starts using the pathfinding algorithm. He can safely drop, but then I want him to go up here. If I use the cell phone test, see, he can't make it. So watch what happens. He will test a straight line here. Can't make it. I gotta pathfind. So I pathfind my way. Now we can reach the entity or his target position. So I'm gonna add more AI. Now I'm gonna let them move to my target position. Okay, you can see they're all trying to push to get inside to here. So now, let's see, I'm going to want them to move here. See now, I'm going to slow it down. They're all pathfinding using the algorithm normally, right? Now, if they have line of sight to the yellow position, they're going to move into the B line. They're going to go straight for that position. Let's move it over here. The entities cannot safely move there in a straight line, so they got to use the pathfinding system. So now they're all walking. But let's see, when they finally get to see line of sight, they'll start moving in a straight line. How the code works is this. The AI will find the closest node that is next to this 3D position. So I want them to move here. The AIs will look for every node and try to see which one is the closest. This one is the closest, and then they will try to work their way to get to it. So the first step is to, if you can do a straight line, do a straight line. If you can't, do the pathfinding algorithm and get to the end of the path. If you're at the end of the path, then move right to the 3D position. Or if you can safely do a straight line at any point, just do a straight line and move. Break out of the path and start moving to it. And that's what they're doing. So those two steps are the A star algorithm, and then after that the straight line movement. My mouse is a little broken. There you go. See how they're moving. Sorry for all this little debug information, but so now they're moving, they're following my mouse in a beeline position because it's nice and flat. Wherever I'm going is nice and flat. They can get to it safely with a straight line. Then I'm going to click over here. Oh no, they can't do a straight line, so they got to do the pathfinding. And they were successfully able to get to that position. The next thing I needed to do was jumping over gaps. I didn't want to have to use node blockers on every single gap or unsafe node or unsafe position, and I didn't want to leave markers anywhere to say that this is a gap. That's just too much. So let me delete some of these guys. Sorry. Let me delete these AIs so it makes a little bit more sense. It's easier to see with all this trash going on. Okay. So this AI, I'm going to get them to move over this gap. What happens if you see a little purple dot, the purple square? That position, under that position, if there's a gap there, the AI will do its jumping routine or just not routine, we'll just change its z-axis with gravity after. And this, let me try it again. See? The gap, you might, I don't know if you caught it, but yeah, there it is. This is the jumping position of this entity. If the entity sees, it can have if the AI can see, if he can see this line of sight check to the purple, that means he's quickly moving over a gap. He needs to be able to jump over it. So slow it down, he jumps. There you go. So that's jumping over gaps, and now we need to be able to, let's see, we want to be able to leap over, bring him here, we want to be able to leap over small obstacles. Okay. So I want the entity to move here, that little purple position. If that purple position is inside something, the trace check hits something, it will push him upwards. So I don't have to make a marker of whether this is a wall or whatever. It's just something he will be able to vault over. And hopefully later, I'll be able to add an animation for him to vault over. And there he goes. He's been able, these AIs so far, I've been working on this for maybe 3 or 4 months. And this is probably the hardest, most complicated thing I've ever had to do in a video game, as development-wise. You can't just work on a star by itself. It needs to be integrated into everything else: the gravity, jumping, collision detection, avoidance with other AIs. You can see here, these AIs, they're like kind of pushing each other. Let me see. Let me move them down here. Okay, so if you can see this little network, these little lines, little triangles, it means that these entities are bumping into each other in a sense. Let me add more. If you can look at them, it's a little honeycomb kind of positioning, because they're all pushing each other. And this helps because they're not actually colliding with each other, but they're moving away preemptively. So their boxes aren't colliding with each other, and it actually helps with the frame rate to move them away before they actually hit each other. And that's when a lot of, the frame rate will slow down if you have too many collisions at once. See, now they're in a honeycomb position because they're all pushing away at each other to make sure. And when you smooth it out with the second entity as their their character model, they line up pretty nicely, like in a honeycomb. I'll talk about doors later. Not really fully implemented yet, but yeah, they were able to push doors and stuff. So ultimately, Swordlord is going to be pretty big levels. Not small enough, not big enough to be open world, but not small enough to be an arena. Swordlord 1 was all about arenas. And this one I want to have a little bit of exploration, kind of interesting environments, or just kind of more realistic environments in a sense, or like pathways, tunnels, doorways, building structures, everything. And I couldn't just do, the type of Doom 1 pathfinding where you hit a wall and you just move away randomly and try again. I can't really do that, especially for a little bit more realistic characters. So this is currently where the pathfinding is now, and that's actually in a really good spot for me. There's minimal stuff I got to do in the level. I pretty much have to lay out the nodes, be sparse when it comes to open environments, and use some node blockers to prevent nodes from seeing each other. And in the final version, these node blockers will delete themselves, so I can save on whatever. So yeah,